Thermal expansion. Thermal expansion is the change in size of an object because of a temperature change. There are two basic types of thermal expansion. The first type is known as linear expansion. So linear expansion, if you can see from the animation here, we have a rod or an object of certain length. Once we apply heat to that object, it changes in length, so it expands in length. Now alpha is what we call the coefficient of linear expansion. So coefficients of linear expansion are essentially equal to the change, and in this case, so alpha would be the change in length divided by the change in temperature. So it's the rate of change of length over a certain change in temperature. The next type of thermal expansion is volume expansion. So in volume expansion, if we look at the animation here, assuming or pretending that this box is three-dimensional, once we apply heat to this object, its volume expands. So let's watch this happen. So the volume expands, it gets larger. Beta is what we call the coefficient of volume expansion, and similar to alpha, it's the change in volume over a change in temperature. Alright, next up. So now we know what alpha and beta are. Let's actually apply them in formulas or equations. So the two equations we'll need to know are delta L, which is the change in length. Okay, change in length equals alpha, which we just went over, is the coefficient of linear expansion. And then this L0 term is the initial length. So it's times the initial length times the change in temperature. Similarly, delta V, change in volume, equals beta times the initial volume times the change in temperature. The only two new units here, or the two new variables I should say, are alpha and beta. Alpha and beta are expressed in, so alpha and beta are expressed in units of c to the negative 1 or k to the negative 1, which is just simply 1 over c or 1 over k.